Good day everyone. This time we will learn about some of the applications of differential equation. One of these is the Newton's law of cooling and warming. Newton's law of cooling and warming states that the temperature of a body changes at a rate proportional to the difference in temperature between the body and its surroundings. More precisely, let T denote the temperature of an object and T sub 0 the ambient temperature. If T denotes time, then the Newton's law states that dt over dt is equal to negative k times t minus t sub 0 where k is a positive constant. Thus, if the object is much hotter than its surroundings, then t minus t sub 0 is large and positive, so the object cools quickly. If the object is only slightly hotter than its surroundings, then t minus t sub 0 is small and positive and the object cools slowly. So one of the example of this law is you take an ice cream out of the freezer, keep at negative 18 degrees Celsius. Outside, it is 32 degrees Celsius. After 1 minute, the ice cream has warmed to negative 8 degrees Celsius. What is the temperature of the ice cream after 5 minutes? So this is now the solution. Let T be the temperature of the ice cream in degrees Celsius after T minutes out of the freezer. So we will use the formula for the Newton's law of cooling and warming, which is dt over dt equals negative k times T minus T sub 0. So substituting the given, we have dt over dt equals negative k times T minus 32. So this gives dt over dt equals negative kt plus 32k. So knowing that k is a constant and solving this differential equation, this gives a general solution of t equals ce to the negative kt plus 32. So if we have t equals negative 18 when t equals 0, so we will use the equation t equals ce to the negative kt plus 32. So we have to substitute negative 18 to t as the temperature and 0 to t as the time. So we have negative 18 equals ce to the negative k times 0 plus 32. So if we have t as 0, so we only have negative 18 equals c plus 32. Then we have to simplify. Negative 18 minus 32 equals c. So the value of our c is negative 50. And then again, if our t is negative 8 when t equals 1, again we will use the equation t equals ce to the negative kt plus 32. So our t now is negative 8 and our t for the time is 1. So we have negative 8 equals negative 50 to the negative k times 1 plus 32. So this gives negative 8 equals negative 50 to the negative k plus 32. So negative 8 minus 32 equals 50 to the negative k. So simplifying, we have to divide both sides to negative 10. So we have 4 equals 5 to the negative 5k. So our k here is equal to logarithm of 5 over 4 to the base of e. So to answer the final question, we have to substitute 5 as the value of t for time. So again, we will use the equation t equals ce to the negative kt plus 32. So t is equal to negative 50e to the negative log of 5 over 4 to the base of e times t plus 32. So we have t equals negative 50 times 4 over 5 to the power of t plus 32. So, remembering our t is 5, so we have t equals negative 50 times 4 over 5 to the power of 5 plus 32. So, if we evaluate that one, our t is equal to 1,952 over 125. That is approximately 15.6 degrees Celsius. So this is the answer for the questions. What is the temperature of the ice cream after 5 minutes? So the final answer is 15.6.
So in continuation with our discussion on our topic, so here we will try to solve example number 2. So it takes 15 minutes for an object to warm up from 10 degrees Celsius to 20 degrees Celsius in a room whose temperature is 30 degrees Celsius. So assuming Newton's law of cooling, how long would it take to warm up from 20 degrees Celsius to 25 degrees Celsius? So at this point of time, we are going to determine that I'm required to obtain the 25 degrees Celsius. So from the formula that was being discussed a while ago, so we have the change of the temperature with respect to time, which is equal to the proportional constant K times the difference between the T minus Ts, or the difference between the time of the object minus the time of the surrounding. So if we are going to integrate that formula, we will have an answer of Ln times the difference between the temperature of the object minus the temperature of the surroundings equal to the proportional constant times time plus c. So that is the formula if the process is in cooling. So if the process is heating, so we have the second formula, which is Ln times the difference between the time temperature of the surrounding minus the temperature of the object equals to the proportional constant k times the time plus c. So from the example on the second example, so it says here that how long would it take to warm up from 20 degrees Celsius to 25. So the process is warming up. So that would be in the process of heating. So we will use the second example, or the second formula, which is the Ln times the Ts minus T is equal to K times T plus C. So we have here the three conditions. So in the first condition, the temperature is 0, and the time is 0 and the temperature is 10. So in the second condition, the time is 15 minutes and the temperature is 20 degrees Celsius. And the third condition, which is the time is unknown, we're going to solve for the time if the temperature is 25 degrees Celsius. So the temperature of the surroundings is 30 degrees Celsius. So by this formula on the first condition, so that on our first condition, so we have the time is equal to 0 and the temperature is 10 degrees Celsius. So we just have to substitute the following given. So Ln times 30, which is the time, temperature of the surrounding, minus 10, which is our temperature in condition number 1, is equal to the K times 0, or times T, then plus C. So which is equal to C is equal to Ln times 20, or C is equal to 2.99. So that is our constant in the first condition. On the second condition, we have this temperature of 15 minutes, and the time is 15 minutes and the temperature is 20 degrees Celsius. So from that, we just have to substitute the givens. So Ln times 30, which is our temperature of the surrounding, minus 20, which is our temperature of the object at the second condition, is equal to the constant proportional times 15, which is our time in the second condition, plus Ln 20, which is our constant in the first condition. So we will have the K is equal to Ln 10 minus Ln 20 divided by 15. So our K would be negative 0.0462. So now for our third condition, so we have need to determine the time. So T is unknown and the temperature is 25 degrees Celsius. So we need to determine now how long it is required to obtain a 25 degrees Celsius temperature. So from the formula, from the equation, we now have our T is equal to Ln times the difference between the temperature of the surrounding minus the temperature of the object minus C all over K. So we need now substitute the values. So T is equal to Ln times 30, which is our temperature in the surrounding, minus 25, which is our temperature on the third condition, minus Ln 20. So that is the C that we got from the first condition all over the K, which is negative 0.0462, which we got from the second condition. So that's it. So that the answer would be now T is equal to 30 minutes. So meaning to say that we need to have a 30 minutes period in order to get a 25 degrees Celsius of temperature. So I think that would be all.